Looking up global testing strategies, they vary very widely. The responsibility is often on the owner of a facility. So a hotel owner might have to specify the testing regime for Legionella bacteria. It might also be down to a water safety group. I mean, if you look at a hospital's water safety group, it involves facilities, it involves infection control. There are a lot of people, they have to all meet and agree upon a testing regime. It's extremely complicated. Sampling locations vary. Hot and cold water systems are primarily targeted, but then also cooling towers, because of this additional risk with aerosolization. Cooling towers and condensers have to be brought into the testing regime. The methodology is very complex, and I'll cover this a little bit more shortly. And the requirements for whether we test for Legionella pneumophila specifically, or more widely for Legionella species, varies from country to country and from location to location. Also, the actions that are taken following detection of one or more of these species of bacteria varies depending on the scenario we're in. Just looking at example target levels for piped water systems. In France, the target is less than 1,000. In Germany, it is exactly 1,000. How you hit that, I don't know. And then in the United Kingdom, our guideline target value is less than 100 Legionella, typically per litre of sample. When you start looking at the example actions, you can see that again there's more variation, but there are also vagaries surrounding this. So in the United Kingdom, if you detect Legionella from 100 to 1,000 per litre, your action is going to depend on whether you've got one sample that's positive or 10 or 100. It's pretty vague, so the people maintaining the facilities that have to take these actions are having to act on guidelines that are not really specific. And then if it's greater than 1,000, the risk response obviously goes up, and you have to act more positively, but again, it's still vague. And again, then in the United States, greater than 10,000, prompt cleaning and or biocide treatment. Well, what does that mean? What's prompt cleaning and what biocide are you going to use to do that? It's pretty vague. The people that write the guidelines protect themselves and put the onus onto the building owner or the facilities managers to make those decisions in line with the guidelines, but it's not clear cut. There's some grey areas there for sure. So we'll look at the different scenarios in a couple of locations, and we'll look at some of the testing methodologies that we use. The one exception in the US is the US Veterans Administration. So they have over 170 medical facilities where they're looking after US veterans. And they are very specific about their testing. They want all hot and cold water systems tested every 3 months. 10 outlets from each system have to be tested. It has to be done by accredited bodies, which go through proficiency testing. And they specify 0 Legionella pneumophila per sample volume. And the limits are 0. You cannot find any Legionella pneumophila in that water sample. And having that specific guideline is really helpful. If we move to the International Standards Organization, which is followed by the EU, it's looked upon by Australia, New Zealand, you're all involved in creating these standards. Before 2017, it was decided that the methodology was too complex and very cumbersome. So it was revised, and the new revision emerged in 2017, and this is what they came up with. And it's still extremely complicated and extremely cumbersome. And as an example, for clean water, people will take a 1 litre water sample, and depending on whether they have a high level of contamination or a low level of contamination, they're doing a number of different procedures to try and detect all Legionella species. So up to 12 plates per litre sample from one location. It's a huge burden, and it's because the test isn't really a method. It's a set of procedures that are designed as a catch-all to try and detect all species of Legionella. It's attempting to do a little bit too much. And there are some consequences to that, which I'll come to in a little bit. In Germany, they do about 3 million tests for Legionella per year. Any building where the public is coming into contact with water has to be tested every 6 months. So there's a very high level of testing. They follow a version of the ISO standard where they're either doing membrane filtration with a treatment or they're doing direct plating. Whichever result gives them the highest count, the highest interpretable count from these two procedures, they will take that as their result. They're focusing on Legionella species again, so they're using this methodology as a catch-all to try and detect all Legionella species. By the way, there isn't a method that detects all Legionella species. It does not happen. In France, things are a little bit different because they also follow a variation of the ISO standard method. Again, they're doing membrane filtration with some treatments, or they do direct plating, but they're focusing on Legionella pneumophila. They know that they should be acting primarily on the result where they detect Legionella pneumophila, and so they're only interested in pneumophila. So rather than running this whole gamut of procedures, they'll focus on those that give them the best chance of finding pneumophila. So they're very specific to that end. In New Zealand, there's a little unique situation that I did want to cover, and we can talk about this a little bit more perhaps afterwards, and Nick can perhaps give some input. But there's a study that's just been published within the last few weeks where they're looking at Legionellosis, pneumonia, and Legionnaire's disease in specific scenarios, and they've found that the majority of cases of pneumonia are actually caused by a different species of Legionella. It's not pneumophila, it's called Lombichii. And it's found predominantly in soil and composted materials. In this case, if you were testing for pneumophila, you might not find it. But to me, this is a niche scenario where you should also have a more specific method for that particular species of bacteria. I'll just go over healthcare facilities, and I'm focusing on the UK primarily because that's what I'm most familiar with. Testing in the UK is governed by the Health and Safety Executive, and they have guidelines for design, installation and commissioning of water systems, and then operational management, and they have guidelines for Pseudomonas and also for control of Legionnaire's disease. They primarily focus on circulated hot water that's at a temperature below 50 degrees or cold water that's at a temperature greater than 20 degrees. So they do these checks and balances on some physical parameters there. They also focus on a couple of areas where the risk of having Legionnaire's disease is going to increase. So in dental facilities where you're producing a lot of aerosols, they focus on that particular sampling location. And in augmented care units, intensive care units, where the groups of people coming into contact with water are at the highest risk level, they really focus on that. So they go through their checks and balances, they're checking water temperatures, they're making sure all the physical parameters are kept within check. But it doesn't always work. You still get situations where you're still going to get Legionella bacteria proliferating, particularly if they're associated with this biofilm. So they still also do routine monitoring of the various locations. And this is an eye test. It's just an example of the kind of water safety plan and action plan that a healthcare facility would have excuse me, in response to in order to try and prevent the incidence of Legionnaire's disease. So, do we have Legionella? Yes, no. What's the count? And these are the various responses. It's extremely complicated for people in this healthcare setting. Looking at cold water systems and the specific responses, if they're finding greater than 100 up to 1,000, their responses are again vague. We mentioned it earlier. If there's only 1 or 2 samples that are positive, they might not do anything. If there's a lot of samples that are positive, they'll probably do their checks and balances and then just put anything back into recommission, anything that's failed. Greater than 1,000, their response is more marked, and they're probably going to decontaminate that system, but it's really still not clear. When we get to the augmented care units, it's a little bit more stringent. So they really, not detected up to 100, they're going to take that really, really seriously straight away, and they're probably going to take that augmented care unit out of commission, decontaminate, resample. That resampling result could take another week, 10 days to get a result back before they can recommission. That's really expensive to do that. And at higher levels, again, their response is going to be more marked and more serious. So that's kind of looking at the global regulatory side. I did want to speak a little bit about Legionella. So Legionella is a product that was developed by IDEX over about 10 years. And when we first started out on this development project, we tried to create something that could detect all Legionella species. And because of all these biochemical differences, just because of certain physiological conditions within those different species, how happy it is in the water system at the time, we found we could not do that. We could not create a single product, a single method that would detect more than 60 different species of bacteria. So we decided to focus on Legionella pneumophila because it's Legionella pneumophila which is causing Legionnaire's disease, and that can be fatal. So that was our focus. We have a very generalized testing procedure. It's very, very simple to do. You're just simply adding your reagent, sealing that in a specific tray, incubating it for 7 days. Again, the Legionella is still growing very slowly, so we have to incubate it up to 7 days to ensure that a sample is negative. And then we can generate our output. We use a very specific tray. It's only for use with Legionella. The tray is gas permeable, and we had to develop that because Legionella pneumophila has an absolute requirement for oxygen. And this is just some of the information that we have when we performed our method characterization. This is all published data. And we're looking at various characteristics such as sensitivity, specificity, the number of positives and negatives. So we think we've generated a pretty good product, but it is only for Legionella pneumophila. And sadly, it can't be used in all scenarios where in the regulations, species is prescribed. To come on to the importance a little bit more, we did a couple of trials. We've done a number of trials now. I'm mentioning 2 that we did in Germany. The first one involved 4 laboratories. And we're looking at really the detection of Legionella pneumophila by either Legionella or the ISO standard as it was at that time. This was 2015. And we found a much higher number of samples that contain pneumophila using the Legionella method than we did by the reference method. So already we're in a situation where these samples, some of them actually contaminated at quite high levels, contained Legionella pneumophila, but the reference method wasn't detecting it either because it's gone through a treatment that's killed it off, or because there's so much background still on the plate that you can't see it. You can't see the wood for the trees. We moved on to a bigger trial in 6 labs, and again we're looking now specifically at detection of Nemophila using Liege Alert to detection of all species by the standard method. And it was actually even more worrying. We had over 800 positive, these are the positive samples, and about 18% of them that did contain Legionella Nemophila were false negatives using the reference method. Because you have this methodology which is so complicated, because it's trying to detect all species, sometimes it misses the one that you really want to be interested in. You have to take this as a snapshot. It's one trial done in a certain number of labs. Every trial is a little bit different and the data produced is a little bit different. But we have now, in numerous trials, many of which are published, found quite a high incidence of false negatives with the current reference methods, which is extremely important. This is just a case study from Public Health England in the UK, and it's some of the comments they got when they evaluated Liege Alert for us. There were a number of samples positive for Legionella, and 70% of those had higher results using Liege Alert than with the reference method used in that laboratory. In 20% of the results, Liege Alert gave a count that was greater than 1 log difference. So when you're looking at your action limits, 0 to 100, 100 to 1,000, 1,000 to 10,000, you could be acting on the wrong level based on the current standard. Overall counts using Liege Alert were statistically significantly higher than those with the current reference method. And again, they interpreted the data to mean that there could be samples that by the standard method were low risk contamination, but actually contained levels of Legionella Nemophila above actionable levels. So somebody interpreting that result may do this when they should have been taking this action. One final comment, which is not in here. Acting appropriately to a false positive is not putting anybody at risk of infection. Not responding to a false negative could do exactly that. And I believe that's the end. I'm happy to answer any questions and just like have a general discussion about everything going on.